Today, we will be learning about, drumroll please, chi-squared goodness of fit. Woo! So today the problem we're going to use has to do with some various high school teams such as baseball, softball, and lacrosse. Okay, so here I've actually found some real data. Oregon Live wants to see if there's a distinct preference between the general population over certain high school teams from various sports. They decided to take a poll with Napa baseball, Banks softball, Westview softball, Jesuit girls lacrosse, Centennial softball, and Liberty baseball. So therefore 6 teams in all. 2,373 people voted. The data will be shown below. So the question here is there a distinct preference in team if alpha used is 0.05? So the point of goodness of fit problems is to find if there is a distinct preference between voters or between people choosing a different thing, or if there is no preference. Alright, so again, in a chi-squared goodness of fit problem, we're asking, is there a preference? So our null, or ho, would be that there is no preference between teams by voters, and our alternative hypothesis would be there is a preference. Below, you'll find the data of each team and the number of votes it received. Jesuit Lax won the most with 1,141, while Centennial Softball won the least with 45. But we're not asking here who the majority was, or who the majority was. We're asking, is there a distinct preference if we're using alpha as 0.05 between different section of voting, or is it relatively similar? So we have step 1. All right, step 1, find the critical value. There we use F5 inverse chi-square, which would be found in our stats list editor. Here we're going to be asked about our area and our degrees of freedom. So for area, since a chi-squared is always a right-tailed curve, you're going to use 1 minus your alpha, so 1 minus 0.05, which equals 0.95. So 0.95 is your area. Your degrees of freedom are the number of categories minus 1. Therefore, since there are 6 categories, 6 minus 1 is 5. All right, so we calculate that, and our inverse is 11.07498. So this is our critical value. Our next step is to find the test statistic. The test statistic is found by entering your data into list 1 and list 2 of your stats list editor. So in list 1, you're going to put in your expected data. You find your expected data by taking the total number of people voted, so that'd be 2,373, and dividing it by 6 because there are 6 groups. This is what you would expect if there was no preference and people voted exactly the same. So the number you would find here is 395.5. You're going to enter this into list 1 of your data 6 times. In list 2, you are going to put your observed data. Your observed data is what you see right on the graph. So you'd put 1141, 683, 184, and so forth. On the next slide, I will place the data again in the data table and an example of it in list 1 and list 2. Alright, so here's the chart again, and here's what it should look like in your calculator. From here, you're going to go to F6 by hitting second F1 and go down to number 7, which is chi2 GOF. So after you hit F6 chi-squared 2 GOF, into observed list, type list 2, and into expected list, type list 1, because that's where that data lies. Your degrees of freedom are 5. Hit enter to calculate. The screen on the right should pop up with your results. They give us a large chi-square value of 2,319. Our p-value is obviously greater than 0.05. So now we remember our critical value was 11.07, and our chi-squared test statistic was 2,319.5. Therefore, since our chi-square test statistic falls in the shady region of the curve, we reject the null. Therefore, there is a preference between each of these high school sports teams by the voters. Also, congrats to Jesuit Women's Lacrosse on Oregon Live Team of the Week.